Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. This week on the podcast, we're featuring a series of shows that highlight just a few of the great innovations and innovators at the intersection of three very important and familiar topics: data science, the Python programming language, and open source software. To better understand our listeners' views on the importance of open source and the projects and players in this space, I'm conducting a survey, which I'd be very grateful if you took a moment to complete. To access the survey, visit twimlai.com/Python survey. Please hit pause now and we'll wait for you to get back. That's twimlai.com/Python survey. Before we dive into the show, I'd like to send a huge thanks to our sponsor for this series, IBM. Speaking of open source, IBM has a long history of engaging in and supporting open source projects that are important to enterprise data science. Projects like Hadoop, Spark, Jupyter, and Kubeflow, to name just a few. IBM also hosts the IBM Data Science Community, which is a place for enterprise data scientists looking to learn, share, and engage with their peers and industry-renowned practitioners. There you'll find informative tutorials and case studies, Q&As with leaders in the field, and a lively forum covering a variety of topics of interest to both beginning and experienced data scientists. Check out and join the IBM Data Science community by visiting ibm.com/community/data science. All right, everyone, I am on the line with Luciano Resende. Luciano is an open source AI platform architect at IBM and part of the Center for Open Source Data and AI Technology there, also known as Codate. Luciano, welcome to This Week in Machine Learning and AI.
Hi, Sam. Thanks for having me.
So, Luciano, it is great to have you on the show, and I'm looking forward to chatting with you about a project that you spent a lot of time working on, in particular Jupyter Notebook and the Jupyter Notebook ecosystem. But before we dive into that, I'd love to hear a little bit more about your background and how you got started working at this, the intersection of open source and data and AI.
Great. Let me start. So, I've been working with open source for a long time. I've been contributing to projects at Apache and other areas on the open source ecosystem for over 10 years. And more towards getting into this Jupyter ecosystem part, a couple of years ago, we started seeing a more and more adoption of the notebooks as a way for doing interactive development for data science, and recently for AI as well. And when talking to external or internal customers, we had a need to basically scale that platform for a large number of concurrent users. So you go to a financial institution and they might have 500 data scientists that comes in the morning, will launch their notebook, and they need to be able to do all the crunch of the data that they have to start getting insights from that. And we didn't have a very good solution for that. We also were looking to building the IBM platform, the Watson Studio, and we needed a similar solution. And that's how we started the Jupyter Enterprise Gateway. Basically, what we do in Jupyter Enterprise Gateway, we are a lightweight, multi-tenant, scalable, and secure gateway that enables Jupyter Notebooks to start sharing resources across an Apache Spark cluster or a Kubernetes clusters. And we focus a lot on the enterprise and cloud use cases for that.
I'm starting to hear quite a bit of interest on the part of enterprises and folks that are working in building out platforms and infrastructure for data science and machine learning teams about the idea of kind of standing up Jupyter Notebook instances for their teams. As you kind of think about the way Jupyter is being used in large organizations, what are some of the big challenges that folks run into?
So Jupyter Notebooks, they are evolution from Python console. And because of that, we see it some limitations that came from that past instances. In Jupyter, by default, it's a single user kind of like environment, and all the kernels, which are the actually runtime of the that executes the code, it's default to run as a local process. And what we see is that it doesn't scale to the needs that we need on enterprise or large deployments. And then on the Jupyter ecosystems, we started seeing a lot of like projects that kind of like build it as an add-on to Jupyter and start solving some of those limitations. And the idea is that at the end, you can start building a self-service platform for data science and AI. So when we look, for example, Jupyter Hub gives you the ability to start providing multi-user authentication for those notebooks. And then Jupyter Enterprise Gateway starts to scale the runtime and distribute that into either a Spark cluster or Kubernetes cluster. And that's the direction that we are seeing things go into the Jupyter ecosystem at these days.
Okay, yeah, that was going to be one of my questions. The differences between Jupyter Hub and Jupyter Enterprise Gateway. Is it all about kind of where the backend kernels are run, or are there other differences?
So, as I mentioned, we need a way to start launching an environment for multiple users. So provide a multi-tenant support. And what Jupyter Hub does, it's kind of like a launcher of a Jupyter server. So each user that requests an environment gets a Jupyter server runtime for doing its computation. Then when you get that environment, you then start using multiple notebooks. Those notebooks require a kernel to execute the code. And then that's when Jupyter Enterprise Gateway comes into mind, so that you can have a very lean Jupyter server environment launched by Jupyter Hub. And the runtime then it goes across a cluster, and you can start having multiple notebooks at the same time. But if you close a notebook, you let go those resources and make it available to other data scientists on the platform. It also enables you to start sharing more expensive resources, like, for example, if you're doing AI and you need GPUs, we provided a way to containerize that and then be able to associate the number of GPUs, for example, or the resources per kernel that it gets launched. And because those are decoupled, those come and go as you're using them, and not necessarily the whole time that your notebook server is up.
Okay, so it sounds like then the typical organization will use both Jupyter Hub as kind of the front end and then Enterprise Gateway as a way to distribute the back end kernels, but they're not alternative products, they're complementary or
They are
projects.
definitely complementary. They work very well together. Yes.
So you mentioned both Spark and Kubernetes as services that you can use to provide the backend distributed computing framework for these kernels. What's the current mix that you see of those two options? Is one more popular than the other?
I think it really depends on the type of workloads that you're processing. What I see Spark get used is more for like analytics, where you have a lot of like data, and you want to start processing, crunching those data, and then applying some kind of like a machine learning on top of that. And we, with the recent release that we have, the Enterprise Gateway 2.0, we support not only if you have like a legacy Spark deployment based on like a HDFS and Hadoop distribution, but we also support Spark on Kubernetes. So if you're doing analytics, you're most likely going to use the Spark runtime, and that's why we initially started supporting that. With more the AI workloads, what we have seen is a lot of like AI platforms for training models and deploying models, all based on Kubernetes. And the reason I think for that is that Kubernetes provides you kind of like the right sandbox with containers. And that enables you to, for example, start a Python kernel. But if you're doing a TensorFlow model, you just come and say, okay, I want a Python kernel based on a TensorFlow image. And you start mixing and matching your environment with the kernel that you need. And then you can have a very specific environment enclosed in the container. And another AI engineer might completely have a completely different one, and Kubernetes manage and all the deployment, anything that needs to happen on that, and we manage the life cycle and give the connectivity to notebooks to be able to actually execute and train your models on a Kubernetes environment.
Now, I've had several conversations with organizations. Airbnb is one that comes to mind that have invested pretty heavily in customizing Jupyter Notebook. And in some ways, maybe they've duplicated what you've done, or went to build it because what you've done either wasn't ready on their time frame, or didn't offer features that they needed. And I'm wondering, in general, where do you see folks investing heavily in customizing Jupyter to build it into their workflows? Like, what are some of the key gaps maybe in what's currently available, or some of the ways that organizations might want it to be more tightly integrated?
What I've been seeing on the industry is a lot of like customization around like your internal environment and integration with some of the tools. You might need to get some of the outputs of your notebooks into a given platform that is available only internally. And that's a lot of the things that I've been seeing. And when you go, I think with Jupyter Lab, which is a new UI for the Jupyter Notebook, uh, those kind of customizations and ability to start bringing up widgets are going to become much more flexible and easy to deploy or customize. And then in terms of like runtime, I think what I've been seeing is a lot of like trying to accomplish multi-tenant by deploying multiple environments for different users, but it's a duplication of that environment and not like a decoupling the actual execution of the kernel with the Jupyter Notebook. And that's how Jupyter Enterprise Gateway came to be.
Can you elaborate on that last part when you say it's a duplication? In what sense?
So Jupyter Hub, as you were saying, was available prior, a lot prior than Enterprise Gateway. And initially, what I've seen people doing before Enterprise Gateway is that they will start a Jupyter server for each user, and then that instance of the Jupyter server will have to have all the resources required for any type of workload that the user needs to do. That is an okay solution, but all those resources get locked for a long time. And in that case, I think a lot of those resources might be in an idle position and not be able to be reused by other members of your platform or other data scientists that wants to do some computations.
You also mentioned kind of integrating with internal systems and security and things like that as a big motivator for folks. Are the Jupyter Notebook and this kind of ecosystem APIs, do they lend themselves to folks doing this kind of integration? Is it difficult? Like, where is it on the scale of built for this and easy to do, or really difficult to do and requires a lot of jumping through hoops?
That's a good question. Let me look into different perspectives here. So imagine you're a data scientist and you're doing running your workloads with Jupyter. You will not see any difference in terms of like user experience if you're using Enterprise Gateway on the backend or not. If you are a kind of like DevOps and you are providing that environment for your data scientists, pretty much what you need to do is customize the kernel definition And instead of saying that it's just a local kernel, you switch to a different lifecycle manager and say this is a remote kernel. We call it process proxy. We have different lifecycle managers for each resource manager. So we have one for Yarn, we will have one for Kubernetes, and that is extensible. So people have been coming and providing others as well. And depending on the one that you choose, the resource manager that you choose, you can then add additional information needed. So like, for example, if you choose Yarn, you might want to pass like your Spark home information. If you choose Kubernetes, you might not need anything specific, or depends on how it goes into terms of configurations. But once that is properly configured, we handle most of the hard work internally on the tool by automating all the life cycle, like starting the kernel remotely, figuring out where it actually launched, providing the configuration back to Jupyter so that the end-to-end communication can be connected. So it's to a certain extent not very hard to get an environment going. And we also have been doing lots of tools like Ansible scripts where you can deploy Enterprise Gateway from scratch or from an existing environment for both Spark and Kubernetes runtimes.
And so the work to create this remotely executable or invocable kernel, was that already in existence in the Jupyter ecosystem, or is that part of the work that Enterprise Gateway needed to do in order to exist, really?
Yes. So the kernels in itself is nothing new that we created. The kernels were available before in Jupyter, and today I think we have a list of like over 100 kernels available. The kernels they will abstract the languages that you are using. So, for example, if you are doing Python, you have a Python kernel. If you're doing Scala, you have a Scala kernel. What Enterprise Gateway brings is the ability to decouple those that originally were running as local process to be run remotely. That's the main thing that Enterprise Gateway brings. And around that came a lot of requirements such as security, how to handle multi-tenant so that the users that are actually requesting the kernel are the ones that are running the kernels on the runtimes as well. And we started leveraging the capabilities that we had to handle all of those additional requirements in Enterprise Gateway.
I'll occasionally hear from folks that are using Kubernetes for these types of workloads that they run into challenges with the kind of out-of-the-box Kubernetes scheduler. Is that something that you've seen for running these kernels?
We haven't experienced any particular issue with the schedule at the moment. We also haven't heard from any users. I think most of the users at the moment are going more for the Kubernetes environment, and we haven't heard anything specifically to that from them yet.
I guess that one of the other things that I hear from folks about kind of the way they want to use Jupyter is to integrate it with, for example, more tightly with Git repositories and shared file systems, and kind of have these resources easily accessible by data scientists and machine learning engineers, kind of wherever they spin up their notebooks. Is that something that you see as well? And is it a piece of what's offered by the current notebook ecosystem?
That's definitely something that I hear a lot. I think the Jupyter Notebook and as well the new UI Jupyter Lab have the ability to have extensions built on top of that. Particularly on the Jupyter Lab, I've seen, for example, integration with Git repositories, and you can easily or transparently get things back and forth based on how you're progressing with your notebook. I think another thing that I also hear a lot, and currently I don't think it's available, or at least not easily available on the open source, is the ability to start doing collaboration. that is something that like sharing and having multiple people look into the notebook and maybe try to collaborate on that. I think it's one thing that really needs to come and be available on the open source and the Jupyter ecosystem, and that's not available today.
Yeah, I think Google Colab is an offering that comes to mind that does a pretty nice job at, showing what a collaborative notebook experience might look like. And I can imagine that's kind of creating a lot of demand for folks that want to use something similar, but in a native Jupyter type of an environment.
That is correct. I mean, I've seen commercial solutions that start offering those, but in the open source or more like on the academia, we haven't seen an open source solution that handles that.
Okay, you mentioned that there are hundreds of kernels for Jupyter, which I actually find kind of surprising. I mean, I don't. When I click down that kernels button, it only ever says Python 2 or 3. I'm wondering, to what extent my experience is reflective, broadly or in general, like how much of the Jupyter ecosystem is kind of Python centric and is Python users and how much of it is folks that are trying to do other things beyond Python?
I think that three, at least commercially, like on more enterprise environments, what we have seen is Python the number one, R the second, and those are mostly data scientists. And then some data engineers, particularly the ones working on analytics workloads, they also use Scala for particularly integrating with Spark. And you mostly see Python because Python, like if you have an environment like Anaconda or any other way, Python most likely will be natively available for you. The other kernels are, you can easily install those. They will just, after installation, start appearing as one of the options into your Jupyter Notebook environment. And particularly in academia, then you start seeing Julia, C++, and other kernels that are very used on that community. So and that's why you have a list of like over 100 kernels available today.
Okay, and for folks that are, are there specific companies or examples that you can share about, what folks have managed to do with the Enterprise Gateway?
One of the examples that I can give you internally is IBM Watson Studio. In order to be able to scale the notebook environment that we provide as part of Watson Studio, we use Enterprise Gateway to not only remote the kernels, but also to give you a choice on where you want to run those kernels. We have different runtimes that we support, and you can select those runtimes as where you want to run where you want to have the execution of the notebook runtime. Another example, and this is just from Strata. We were at Strata yesterday, and PayPal was giving a very interesting presentation on how they were using Enterprise Gateway to be able to build their internal platform for data scientists and AI. So these are two examples that comes to mind. There are probably more, but particularly because we are open source, we only hear from them when they have an issue that gets reported, or maybe like through a conference or something like that.
Is it currently at a production-ready state? Sounds like PayPal, at least, and IBM are using it in production. How mature would you say it is?
So we have two code streams that we are maintaining at Jupyter Enterprise Gateway. We have what we call the 1X release, which supports Spark, is mostly focused on analytics workloads, and that has been stable and being used like internally by products and a lot have been available in the open source for a long time. Probably over a year or around close to a year and a half. And we have maintaining that in terms of like any new bugs that we see around that or any dependencies that needs to be updated for security reasons or anything like that. In parallel, we then are working on our 2.0 release, which 2 days ago we launched the 2.0 RC1, release candidate 1. And that brings a lot of like innovation that we are doing on Kubernetes environment. Having said that, based on the questions and issues that we are getting, we have seen a lot of people experimenting, going more towards that direction and using the tool already to build their analytics environments on top of Kubernetes. So, and hopefully that will also be available as a GA in the next couple of weeks, based on whatever feedback we get from the RC1.
And is the enterprise gateway functionality independent of the kernel that's being used, or are there some limitations or dependencies there?
So it is supposed to be independent. What we have done, we created a layer called Kernel Launcher that give us the ability to enhance the kernels functionality, particularly for startup and shutdown. And we have tested a lot with the Python, DR, and Scala kernels, which are the most requested and the most used for us. And things that we do is like, for example, if you are starting a kernel and that kernel is connecting to Spark, we create, for example, a parallel thread to start the Spark context. So it gives you a better and quicker user experience for the startup of the kernel. We need the ability to provide remote signaling, so you can hit like stop the kernel and things like that. And we need to flow that externally to a remote kernel. And the launcher kind of does that as well. But that kernel launcher can be easily ported or used for a different kernel. So the addition of new kernels shouldn't be very hard to incorporate into Enterprise Gateway.
I'm curious about the requirements that users have when architecting environments for Enterprise Gateway. One of the things that comes to mind, for example, is when you're running your kernel locally, you've got typically data locally. If you're starting to remote your kernel, then the kernel's operating against data that's remote. I'm wondering if there are network or bandwidth considerations or any kinds of issues that an organization might want to think about as they're architecting an enterprise gateway environment, and generally kind of how straightforward that process is, or there are tools that are available for like capacity planning, things like that.
I completely agree with the type of considerations that you're bringing up. I just, from what I'm seeing, these are not specific to when you're trying to deploy Enterprise Gateway, and it's a request more in general. So if you're doing analytics, the data will be most likely in a Spark cluster, but in a distributed file system like HDFS or some kind of like object storage environment. And you have like shuffling of data going back and forth, independent if you're using Enterprise Gateway or not. So that should have been part of like planning the deployment of Spark in particularly. If we consider the Kubernetes environment, Kubernetes will most likely have multiple microservices being together to bring up a solution, and you will have similar type of constraints regarding data flowing and any other things like that. The easiest way that I've been seeing in more like a Kubernetes environment is we give the ability to do mappings into volumes into the specific container. And by doing that, you can have the user environment available in that kernel image, and that helps you alleviate most of these constraints by maybe providing data, by maybe providing an environment with the specific packages that you might need for a given user on that mount, and that should solve some of these problems.
Okay. So it sounds like there's nothing particularly exotic or unknown or, that needs special attention here. It's kind of the typical considerations when architecting a distributed environment for these kinds of workloads.
Exactly.
Granted that this is this capability that we're talking about, particularly with Kubernetes, is something that was just announced a couple of days ago or released a couple of days ago. But are there any other kinds of issues that you hear a lot about that folks run into that maybe you wish more people would think about before they embark on this path?
Maybe a little bit unrelated, but in the context of the Jupyter ecosystem, what I see a lot of discussions of what is the notion of a notebook and how it incorporates on your, let's say, model training pipeline and things like that. And most cases that I've seen, people would use the notebook for kind of like evaluation, taking a look at the data and playing with your model, but will actually convert the notebook into a Python file, for example, when they are kind of like ready to do a big training or start getting close to go to production. In my mind, the notebooks can become a little bit more kind of like first-class citizens on those pipelines for model training, and actually be one of the steps, actually be the notebook in itself and not necessarily go to a pipeline as a converted Python file. And I think once we have that, it's going to be much more productive. The data scientists can come up with something that then goes directly into the pipeline, produces the model, and then can recreate the model later on if needed without any kind of like a collaboration maybe with system engineers to convert to a Python or anything like that.
And what needs to happen in order to get there from a kind of Jupyter ecosystem perspective?
We have been seeing tools that it starts to enable that. I think it's mostly in a state of mind of like how people sees the notebooks, and they initially were a lot used for kind of like experimenting with data, trying to understand the data and trying to build models, but not necessarily, maybe because those tools were not available yet, go into production. And I think today we have seen like a Netflix coming out with Papermill, a couple of other schedulers also coming out and supporting notebooks. My hope is that I will start seeing more of that being part of the pipeline for model development.
All right, Luciano, this has been really great. I'm wondering if you've got any final thoughts or tips or ideas for folks that are using Jupyter, maybe as individual data scientists, and want to use it more broadly in their enterprises.
Oh, definitely. I think one of the things that I've seen, and it's interesting that a lot of people still use and know about the Jupyter, what I call like classic UI, but are not aware of like Jupyter Lab. Jupyter Lab gives you a lot of like flexibility and a better UI to do your model development, and that gives you ability to start having like terminals, multiple tabs all together, and provide a much more integrated development environment for the model development.
Awesome. So folks should definitely check that out. Well, Luciano, thanks so much for taking the time to chat with me.
Okay, thanks, Sam.
All right, everyone, that's our show for today. If you like what you've heard here, please do us a huge favor and tell your friends about the show. And if you haven't already hit that subscribe button yourself, make sure you do so you don't miss any of the great episodes we've got in store for you. As always, thanks so much for listening, and catch you next time.